Hello guys, welcome back to my channel. This video is about Gierke disease, which is type 1 glycogen storage disorders. For the step 1, glycogen storage disorders are very high yield. Out of all the glycogen storage disorders, Gierke disease is the most important glycogen storage disorder. Very high yield, very important. So I thought, let us make a video. So it is a glycogen storage disorder. So whatever there is an enzyme deficiency and leading to glycogen storage in liver and kidneys. Before we go into that, this is actually a genetic disorder. There is a gene defect. You don't need to get into the details of what gene it is, what chromosome. I don't think that's important. But the inheritance pattern is autosomal recessive, which is very much important because it is mentioned in the first aid. So it happens due to gene defect leading to the deficiency of the enzyme glucose 6 phosphatase, and the inheritance pattern is autosomal recessive. Now this enzyme deficiency leads to everything we'll discuss in this video today. So first of all, glucose 6 phosphatase, where does this enzyme come? It comes in glycogen metabolism, that is glycogen synthesis and glycogen degradation, glycogenolysis. So this image describes it. So when degradation is occurring, the second to last step is glucose 6 phosphate. The enzyme acts and glucose is formed. Whereas the reverse also happens, that is glucose 6 phosphate is formed from glucose, which then forms glycogen. So this is glycogen synthesis. The reverse is also happening. Glycogen degradation is also happening. So glucose 6 phosphate is the product of glycogen degradation and the substrate for glycogen synthesis. So when the glucose 6 phosphatase is absent, now important thing to remember is our glucose 6 phosphatase is present only in the liver and the kidney, like not present anywhere else, only liver and kidney. So deficiency is also there only in the liver and kidney. That's why we don't see any manifestations in the muscle like we see in other glycogen storage disorders, like muscle cramps or pain or all of those things we do not see in von Gierke's, because the enzyme deficient is anyways not present in the muscles. So that is the point. Coming back to this, so because of the deficiency of this enzyme, glucose 6 phosphate is accumulating in the liver, also in the kidney. This is causing the further problems. First problem is, because glucose is not being formed because of the inhibition of this step, there is decreased blood glucose levels. So what does that cause? Severe hypoglycemia in the fasting state. Now why is the word severe important here? Because we'll see another glycogen storage disease where we see mild hypoglycemia, not that severe. So in von Gierke's, severe fasting hypoglycemia is a clinical feature, and we'll come back to this in a moment. But as I said, glucose 6 phosphate is accumulating. So what is happening is, it is preventing these reactions which are causing the production. That means glycogen degradation, glycogenolysis is being prevented. So it is causing a negative effect on glycogenolysis. Whereas because it is a substrate of glycogen synthesis, it is increasing synthesis. So glycogenesis is being promoted. So what are these two things causing at the end of the day? Where we started, glycogen, increased glycogen, more glycogen is stored in the liver and kidney, so glycogen storage disease. So that is where we see these two things are causing glycogen storage in the liver and kidney. Because of this glycogen storage, glycogen has glucose molecules. Glucose molecules have hydroxyl groups, which causes the glycogen to be osmotically active. This causes water to enter in these organs, more specifically liver and kidney. So this eventually causes what we see: hepatomegaly, enlargement of the liver, and also renal enlargement. So In von Gierke's disease, we see hepatomegaly and renal enlargement. What we do not see is splenomegaly. So there is no splenomegaly. Why is this important? Because in other glycogen storage diseases like Pompey's disease, we see hepatosplenomegaly. So if the question says hepatosplenomegaly, we can rule out von Gierke's because the spleen is not affected in von Gierke's disease. So these three are them. Now one more thing which we see in this diagram is increased glucose 6-phosphate is causing increased glycosis, leading to more lactate. That is one thing that is causing lactic acidemia. So I'm definitely gonna write that down here, lactic acidemia. But so as I said, we'll come back to this hypoglycemia. So what happens is when there is hypoglycemia, decreased blood glucose levels, there is a feedback mechanism. This feedback mechanism causes a release of hormones like glucagon and epinephrine. What do is go and affect the adipocytes. So we come back here. So this is an adipocyte. So what do fat cells have? Triglycerides, stored triglycerides. These triglycerides are actually converted to fatty acids and glycerol by an enzyme called as hormone sensitive lipase. These enzymes actually promote the activity of hormone sensitive lipase, causing more fatty acids and glycerol to be produced. These fatty acids are released in the blood, eventually causing hyperlipidemia. So hyperlipidemia in von Gierke's disease is secondary to the hypoglycemia. Okay, first the hypoglycemia occurs, and then secondary to that, because of the changes happening because of hypoglycemia, is what results in hyperlipidemia. So that is also done. Last thing I'd like to talk about is glucose 6-phosphate is not getting converted to glucose. So this phosphate, inorganic phosphate, is also getting basically depleted, not accumulated. That would be definitely wrong. Depleted, or basically it's not available for AMP to get converted to ATP or to do anything basically. So levels of AMP increase more than the normal amount should be, because inorganic phosphate is being used up with glucose 6-phosphate. So this AMP is a nucleotide. So because of the excess nucleotide, there is excess degradation of AMP, which leads to the production of uric acid, which is the degradation product of nucleotides, or you could say purines. So this causing increased production of uric acid. Also, there is lactic acidosis. There is more lactic acid. So lactic acid has to get excreted, so it competes with uric acid for its excretion. So it also basically contributes towards the increased uric acid levels in the blood, because it's preventing its excretion. So increased AMP degradation and lactic acidosis both together cause hyperuricemia, increased uric acid in blood, which is leading to gout. So those are all the clinical manifestations of von Gierke's disease. Now I'll quickly show you the table that we have in the first aid book. Severe fasting hypoglycemia, increased glycogen in the liver and kidneys, increased blood lactate, increased triglycerides, increased uric acid, hepatomegaly, renomegaly. Because of all this, liver is not able to regulate the glucose properly, but we discussed everything: increased glycogen in the liver, hepatomegaly, splenomegaly, increased blood lactate, increased triglycerides, increased uric acid, and gout. And deficient enzyme is glucose 6-phosphate. Now treatment is what we have to discuss. Frequent oral glucose, right? So or cornstarch will also give glucose in itself, but very important, fructose and galactose shouldn't be given. Even though fructose and galactose will eventually break down to give glucose, their administration to patients of von Gierke disease does not affect or improve the condition by any way. So avoidance of fructose and galactose, frequent oral glucose, and this we already discussed. Glycogenolysis is inhibited, more glycogen storage is there. Gluconeogenesis is affected because even in that we required glucose 6 phosphatase. Because of the enzyme deficient only, both of these are affected. So that's all for this video. I hope you enjoyed it. There's everything you need to know about von Gierke disease, and that's all for this video. Thanks for watching.